Hello, I welcome you all to this another interesting screencast. The problem reads, the winch on the truck is used to hoist the garbage bin onto the bed of the truck. If the loaded bin has a weight of 8,500 pounds and center of gravity G, determine the force in the cable needed to begin the lift. The coefficient of static friction at A and B are mu A equal to 0.3 and mu B equal to 0.2 respectively. Neglect the height of the support at A. So we are just assuming all those differences will not cause any moments when you begin to take moments. Okay. So this particular problem is coming from the engineering mechanics statics textbook, 13th edition by R.C. Hibbeler. So let's draw the free body diagram. Again here the movement is, we want this to move, it's moving in this direction, okay, right? It's going in this direction. This is going to be lifted up, all right? We want it to be lifted up there so that this truck later on will get back to normal and then it drives. Okay, so we are lifting this garbage truck from the ground onto this loading bay, and then take it to for disposal. All right, but there is friction at A, this point. There is also friction at B here, and we've got this cord here is the one that is applying a tension force to pull the whole lot of this, right? So I'm sure it has a motor somewhere here, okay, that pulls this, but as this is being pulled, there is friction acting here against. All right. So let's draw the free body diagram. So at A, of course, we expect a normal force like so, and we also expect the friction force, and friction force, like we said, is always in the opposite direction like so. Okay, there is inclined, so the normal force will be normal to the bed, okay, like so. It's normal to this, okay, that's fine. And then is in this we have this behavior here. I'll draw it like so. Okay, let me just still draw it like this. Okay, like so. Okay, and then here we are going to have a tension force. We have this cable here. Can you see this cable? So we'll have a tension force if we are to cut this particular cable that is connected to a motor that side. Okay, so let's say this is our T, this is our tension. Okay, and then we have a normal force F NA, then we have friction force Fa, then we have normal force NB, and then there we have FB, friction force FB. Okay, so we expect components for each one of these particular forces. The angle there is 30, so we're going to have a component in this direction like so, and another one in this direction. All right, I know it's not very clear, right? All right, okay, let me put it like so. So we'll have this component like so, These are the four, and then we'll have some more components here. The normal force, so we'll have one component like so, and then we'll have another one like so. Alright, and then we'll have some more components. Damn, will my space allow me? Okay, one is going to be in this direction like so, and then another one will be in this direction like so. Okay, alright, we'll label them. We'll still have to label them. So let's start with this. Like we said, this angle here is 30. So we expect this is 30. This is 30. Okay. So we expect this one here to be equal to T. This is T cos 30. Then this one is T sine 30. Okay. And then this angle here is also 30. Right? This is 30. Agree? Okay, check it out. This is going to be equal to NB cos 30, and then this one is also NB sine 30. Alright, and then we have this. Of course, this one here is FB cos 30. This one is FB sine 30. I think we've written down. Again, these forces here, we are assuming they are all meeting at the same point. That is the assumption we are making. Okay, so here we are assuming all these forces are meeting at the same point, which is point B. Alright, and then we have the weight of this material, the garbage that is being hoisted, which is W. Alright. Is it given? Yes, weight is given. So the weight, so how many unknowns do we have here? Number of unknowns. Number of unknowns are equal to that's 1, 2, 3, 4, 5. There are 5. Okay, this is NA, NB, FA, FB, and T. And number of equations of equilibrium we have, of course, 3. So of course we are going to assume there is going to be impending motion at A and B. Okay, moreover we intend to pull this, right? So it just makes sense, impending motion has to exist. So therefore FA will be equal to mu A NA, which is just equal to 0.3 NA, and FB is just going to be equal to mu B NB, and our mu B is just 0.2 NB. So we have all the equations that we need to apply the summation of moments about point B. And like we said, all those points, all the forces we are assuming they are coming from the same point. Okay, so summation of moments about point B and clockwise being our reference. What do we have? We have the following. We have minus NA times 12 plus 10 is a 22 feet, and then we have plus W times 12, right, equal to 0. Okay, again, one would be tempted to also say, but there's some distance here. There is this distance here. We've seen this distance to this point. Point B is elevated because it's already on the platform. But we've been told to neglect this height. Okay, we are saying this height at A will not cause anything, or its cause will be very negligible. This is what is being said. All right. So this has already been put in. And even if it was not going to be put in, you as a person doing the solving should have made that assumption. All right. But if you had those distances, then you can consider them. So the weight is already given is equal to 8,500 pounds. Therefore, our NA is just going to be equal to, so if you calculated NA, so we'll have 8,500 times 12 divided by 22. So this gives us a 36 pounds. All right. Loaded bin has a weight of 8,500. 8,500 times 12 divided by 22, right? That's 36.36. Great. 0.3636. Great. So here we are. We found one. So now let's find we want to find the tension force T. Okay. So now let's find these vertical components and then later on horizontal. So we'll say summation of forces in the y equal to 0. What do we have? We have NA minus W minus FB sine 30 plus T sine 30. What else in the vertical direction? And then we have plus NB cos 30 equal to 0. So how many unknowns do we have here? And we know that FB, so we can write this in terms of NB. So we know FB, we know that FB is equal to point what FB, 0.2 0.2 NB, right? So if we were to work it out now again, so that we factor out the NBs, this gives us NA. These are both numbers, so I'll take it the other side. I'll take these the other side. So I'll say T. This is 0.5. Those that I can simplify them. So this is 0.5 T. 0.5 T minus we have NB and NB there. One is cos. So this one I'll just say I'll factor out the NB. Alright, let me just leave it like so. So 0.5 sorry, we said FB is equal to 0.2, so 0.5 by, that's 0.5, 0.2 by 0.5, okay, it's 0.1, plus cos 30 plus cos 30. All right. No, this is minus, right? So minus 0.5 by 0.2 plus cos 30. So this gives us 0 point. This is a plus 0.7660 NB equals to W minus NA. So we have one equation. So this is minus 0.5 by 0.2 plus cos 30. That's 0.7660. All right. So the other equation. So say summation of forces in the x direction. Summation of forces in the x equal to 0. In this direction being our reference. What do we have? So we have minus FA minus FA. Everything else was in this direction. Where is our t? So plus our t cos 30. Alright, minus NB sin 30 arterials. So we have this and this one minus FB cos 30 equal to 0. So 1, 2, they are negative. Then the others, so it's 1, 2, 3. 1, 2, 3. Okay, so 2 are negative. NB sine and NB sine and FB cos. Alright, so again we know that we can write this starting with the t. So we'll say t cos 30. Then let me work on the other ones. We know what FB is. So FB there, this just becomes a minus. And in fact both of them are minuses, so just sum them up. So that's sine 30 plus 0.2 by cos 30. Alright, so this just becomes a minus 6.6732 NB equals to FA equals to 0.3 NA. Alright, so we have these two equations that we can solve simultaneously. So let me just borrow this one so that I can bring it over here. And I borrow this one also. I bring it over here. That's the reason I wanted them to have this structure, or just for me to make it easier to solve them. So there we go. So what will I do here? I'll multiply. What do I multiply by? So let's say I multiply this. Sorry. I want to find t. Alright, so I can multiply this by I'll multiply here by 0.76 0.6732 and here I multiply by 0.7660. Then I sum up. Right, let's do that. This is substitution method. Right, let's do that. Great. So what do we have? Just grab your calculator. Of course, these parts they go, and then we have 0.5 times 0.6732 plus, right, plus plus 0.7660 times cos 30. All right, and then we have W, which is 8,500. Just 1 minute. I have 8,500 minus NA. Where is NA? That's 4636.36, and close bracket times 0.6732 plus 0.3 times NA, which is 4636.36. Alright, by 0.7767660. We close brackets, then divided by answer. Oh no, the answer didn't come out. Alright, let me write everything. So this becomes equal to we have 0.5 t times 0.6732 plus t cos 30 by 0.7660, okay, equals to W minus NA by 0.6732, okay, plus 0.3 NA by 0.7660. Alright, therefore our T is just going to be equal to, let's work it out now. I think it is much clearer. So 8,500 minus 4636.36 times 0.6732 plus 0.3 times 4636.36 times 0.7660. Alright, so divided by 0.5 times 0.6732 plus cos 30 times 0.7660. Alright, then T is just going to be equal to 66.53 pounds. Alright, so this is what was the question again? The winch and the garbage determine the force in the cable needed to lift. So we need this force, right? We need this force to be able to lift this garbage. Right, so let's outline this. Let's outline it like so. Right. So I think this is about it, and I hope this video was helpful. And if it was, give me a thumbs up. I like my video. Continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.